What if the secrets to life on Earth could help us uncover the existence of life in the vast expanse of space? Could alien organisms be living in extreme environments like those found in our own oceans? And what if planets we thought uninhabitable were teeming with microbial life? Join us as we explore 7 mind-blowing concepts in astrobiology that challenge everything we thought we knew about the universe and the possibility of life beyond our planet. The origins of life, how it all began. Astrobiology begins with one of humanity's oldest questions: how did life begin? Understanding the origins of life on Earth is key to determining where and how life might exist elsewhere in the universe. Scientists hypothesize that life on Earth originated around 3.5 to 4 billion years ago in an environment much harsher than the one we live in today. Theories such as the primordial soup model suggest that life began from simple organic molecules forming in Earth's early oceans. However, there's also the deep-sea hydrothermal vent hypothesis, which proposes that life started in the extreme environments of deep ocean hydrothermal vents. These vents host life forms that thrive without sunlight, raising the question, could similar environments on other planets or moons host life? The origins of life debate don't stop at Earth. Astrobiologists are looking at places like Mars and Jupiter's moon Europa, where conditions may have mirrored early Earth. Organic compounds considered the building blocks of life have already been detected on these worlds, sparking curiosity about whether life ever arose or still exists there. The discovery of extremophiles on Earth, organisms that live in seemingly uninhabitable places like volcanic vents and acidic lakes, has broadened the scope of astrobiological research. If life can thrive in such conditions on Earth, where else could it exist? But what if life didn't start on Earth at all? The Panspermia theory suggests that life could have originated elsewhere in the cosmos and been transported to Earth via comets or meteorites. This possibility means that the origins of life might be a universal phenomenon, not just a terrestrial one. By understanding how life began on Earth, astrobiologists hope to unlock the mysteries of life's potential beginnings elsewhere. Ultimately, the search for the origins of life isn't just about looking backward, it's about searching forward to other planets, moons, and even exoplanets, in hopes of discovering the same cosmic recipe that gave rise to life on Earth. Habitable zones, the Goldilocks principle in action. In astrobiology, the search for life starts with identifying where it could possibly thrive. The concept of the habitable zone, often called the Goldilocks zone, refers to the region around a star where conditions are just right for liquid water to exist. Without liquid water, life as we know it could not exist. Planets within this zone aren't too hot or too cold, making them prime candidates in the search for extraterrestrial life. However, recent discoveries have challenged the traditional definition of habitability. While liquid water is a key ingredient for life, we are learning that life might exist in extreme conditions far outside our initial expectations. For instance, Saturn's moon Enceladus and Jupiter's moon Europa are both well outside the traditional habitable zone. Yet, beneath their icy crusts, scientists believe vast oceans of liquid water exist. With geysers shooting water vapor from Europa's surface, it's become one of the most exciting places to search for extraterrestrial life in our solar system. Beyond our solar system, thousands of exoplanets, planets orbiting stars outside of our solar system, have been discovered, and many reside within their stars' habitable zones. NASA's Kepler mission has confirmed the existence of planets in these zones, leading scientists to speculate about the possibility of life on these distant worlds. But could life exist in ways that don't depend on water at all? Some astrobiologists argue that life on other planets might use chemicals or elements different from the ones we know to support biological processes. This evolving understanding of habitable zones underscores a central tenet of astrobiology. We must keep expanding our definitions and expectations if we hope to find life beyond Earth. The Goldilocks principle, though useful, is just the beginning of our cosmic search. Extremophiles, life in the unlikeliest places. One of the most mind-boggling concepts in astrobiology is the study of extremophiles, organisms that thrive in conditions that would be lethal to most other life forms. These hardy creatures survive in the most extreme environments on Earth, from scalding hydrothermal vents deep in the ocean to the frozen deserts of Antarctica and even within radioactive waste. Studying extremophiles is crucial to astrobiology because they show us that life can exist in conditions far beyond what was once thought possible. Extremophiles are divided into several categories depending on their environments. Thermophiles live in extreme heat, acidophiles in highly acidic environments, and halophiles thrive in places with extremely high salt concentrations. Some extremophiles even survive in the vacuum of space. Understanding how these organisms manage to survive, and even thrive, could be the key to understanding how life might exist on planets and moons with harsh environments like Mars or the icy moons of Saturn and Jupiter. Astrobiologists are especially interested in extremophiles because they represent living proof that life can find a way under seemingly impossible conditions. On Earth, extremophiles are found in places that mirror the environments of other planets. The cold, dry deserts of Antarctica resemble the surface of Mars, while the hydrothermal vents deep in Earth's oceans mimic what might exist under the ice crusts of Europa or Enceladus. If life can thrive in these earthly extremes, it's possible similar life forms could exist in the outer reaches of the solar system and beyond. These findings don't just apply to our solar system. When we look at exoplanets orbiting distant stars, the presence of extremophiles suggests we shouldn't be too quick to dismiss worlds that seem inhospitable at first glance. With every new discovery, we're learning that life is far more adaptable and resilient than we ever imagined. And the study of extremophiles opens up possibilities that are truly out of this world. Panspermia. Did life travel to Earth from space? One of the most intriguing ideas in astrobiology is the theory of panspermia, which suggests that life didn't actually start on Earth but was instead carried here from somewhere else in space. According to this theory, microbial life could have hitched a ride on comets, asteroids, or even cosmic dust, arriving on Earth billions of years ago. This idea challenges the notion that Earth is unique as the birthplace of life and instead opens the possibility that life could be a cosmic phenomenon, with planets like ours acting as receivers. The panspermia theory has gained traction as scientists discover more about the resilience of life, particularly extremophiles. Some microorganisms are capable of surviving the vacuum of space, intense radiation, and extreme cold or heat. If life can endure space travel, even in microbial form, it's not hard to imagine how life from other planets or moons could have arrived on Earth through impacts with space debris. For instance, the discovery of organic molecules on comets and meteorites adds to the evidence that life's ingredients, or perhaps even life itself, could travel between planets. Additionally, panspermia introduces the possibility that life could be widespread across the galaxy, hopping from one planetary system to another. If microbial life can survive the journey across space, it's possible that Earth isn't the only planet to have received such visitors. Mars, which scientists believe once had flowing water and a more Earth-like climate, could have been one such planet. In fact, some speculate that life on Earth might have originated on Mars before migrating here. While panspermia remains a hypothesis, it expands our perspective on life's origins and where we should search for it. If life can travel between celestial bodies, then the universe may be teeming with life, with each planetary system passing the torch of life to its neighbors. As we continue to explore the solar system and beyond, astrobiologists are on the lookout for signs that panspermia may be more than just a theory. Biosignatures, the clues that could reveal alien life. A key part of the search for extraterrestrial life involves the hunt for biosignatures, indicators that life, as we know it, either exists or once existed in an environment. Biosignatures can take many forms, from specific gases in a planet's atmosphere to the presence of complex organic molecules. The discovery of biosignatures would be one of the biggest breakthroughs in astrobiology, offering tangible proof that life exists beyond Earth. One of the most promising biosignatures is the detection of methane on Mars. Methane can be produced by geological processes, but it's also a byproduct of biological activity. The presence of fluctuating methane levels on the red planet has led scientists to speculate that there could be microbial life beneath the surface. In 2020, NASA's Curiosity rover detected seasonal methane spikes on Mars, reigniting interest in the planet as a potential host for life. While methane alone isn't definitive proof of life, it's a strong biosignature that warrants further investigation. Beyond Mars, biosignature detection plays a crucial role in the study of exoplanets. NASA's James Webb Space Telescope and other upcoming missions aim to study the atmospheres of distant planets, searching for gases like oxygen, methane, and carbon dioxide, chemical fingerprints of potential life. One of the most exciting discoveries in recent years was the detection of phosphine gas in the atmosphere of Venus. On Earth, phosphine is primarily produced by biological processes, leading to speculation that microbial life could exist in the planet's acidic clouds. The search for biosignatures is an ongoing complex process, as many signals could have non-biological origins. But the detection of even one unambiguous biosignature would revolutionize our understanding of the universe and our place in it. As technology advances and our understanding of life deepens, the chances of detecting biosignatures beyond Earth are becoming increasingly likely. The Fermi Paradox. Where is everybody? With the vast number of stars and planets in the universe, many scientists believe that intelligent extraterrestrial life should be common. So why haven't we encountered it yet? This question is known as the Fermi Paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" when considering the likelihood of intelligent alien civilizations. The Fermi Paradox points out the contradiction between the high probability of life existing elsewhere in the universe and the complete absence of evidence for it. One possible solution to the paradox is that intelligent civilizations are rare, either because life rarely evolves to the point of intelligence, or because such civilizations tend to self-destruct before they can explore the stars. The history of Earth shows that complex, intelligent life took billions of years to develop, and human civilization has only existed for a tiny fraction of that time. It's possible that intelligent life on other planets may be in an earlier or later stage of evolution than we are. Another explanation is that advanced civilizations are out there but deliberately avoiding contact. This idea, sometimes called the Great Silence, suggests that alien civilizations might have their own reasons for staying hidden, such as not wanting to interfere with less advanced species like ours. Alternatively, they might communicate in ways we haven't yet discovered, using technology or signals that we are incapable of detecting with our current methods. Finally, there's the possibility that the distances between stars and galaxies are simply too vast for civilizations to communicate or travel across in any meaningful way. Even if alien civilizations exist, they could be so far away that we may never encounter them. As we continue to explore space and search for extraterrestrial life, the Fermi Paradox remains one of the greatest mysteries in science. The search for exoplanets worlds beyond our solar system. In the past few decades, one of the most exciting developments in astrobiology has been the discovery of exoplanets, planets that orbit stars outside our solar system. These worlds, once only a figment of science fiction, have become the focal point of our search for life beyond Earth. As of 2024, astronomers have confirmed the existence of over 5,000 exoplanets, many of which reside in their star's habitable zone. One of the most famous discoveries is Kepler 186f, an Earth-sized planet located in the habitable zone of its star. This discovery, made by NASA's Kepler mission, was a milestone in the search for potentially life-supporting planets. Exoplanets like Kepler 186f are of particular interest because they could have the right conditions for liquid water, an essential ingredient for life as we know it. The sheer diversity of exoplanets, ranging from gas giants to rocky Earth-like planets, suggests that there are likely many more yet to be discovered, some of which may host alien life. The tools used to discover exoplanets, such as the transit method and radial velocity method, have revolutionized our understanding of the universe. The upcoming James Webb Space Telescope and other next-generation observatories will be able to probe the atmospheres of these distant worlds, searching for biosignatures and signs of habitability. This technological leap could bring us closer than ever to answering the age-old question, are we alone in the universe? The discovery of exoplanets has expanded our horizons, showing us that planetary systems are common throughout the galaxy. As we continue to explore, the potential for finding life in one of these distant worlds grows with each discovery. Whether or not we find life on these exoplanets, their existence challenges us to imagine the possibilities of life beyond our solar system. As we delve deeper into astrobiology, one thing becomes clear: the universe is full of surprises. From the possibility of life in extreme environments to the discovery of habitable zones beyond our expectations, astrobiology constantly pushes the boundaries of what we think is possible. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us.